universe is under no obligation to make sense to you. Neil deGrasse Tyson. Imagine opening the most advanced camera ever built, pointing it toward the beginning of time, and finding a cosmic rash, tiny red specks, scattered everywhere. At first they looked harmless, like dust on a lens, but astronomers soon realized these little red dots weren't on the telescope. They were out there, floating in the deep past of the universe. And they shouldn't exist. The James Webb Space Telescope was built for one purpose: to look backward in time. Because light travels at a finite speed, every distant object is also an ancient object. Looking billions of light years away is like opening a photo album from the universe's childhood. The first images from Webb were expected to show chaos, baby galaxies, messy clouds of gas, half-finished cosmic structures. After all, the universe itself was only a few 100 million years old. For comparison, our universe today is about 13.8 billion years old. Those early regions should have looked like construction sites. Instead, astronomers found something strange. Tiny objects, bright objects, surprisingly mature-looking objects. The cosmic equivalent of finding fully grown trees in a place where the seeds were planted yesterday. These red dots appeared again, and again, and again. The more scientists looked, the more they found. The problem was simple. According to nearly every model of cosmic evolution, objects this early in history should still be assembling themselves. Gravity needs time. Stars need time. Galaxies need time. The universe had barely begun. Yet these little red dots looked as if they had skipped several chapters of cosmic history. Imagine walking into a kindergarten and finding someone with a driver's license. Something in the timeline doesn't add up. Astronomy has experienced moments like this before. The discovery of pulsars, the expansion of the universe, dark energy. Again and again, the cosmos has a habit of whispering, "You think you understand me. Watch this." And now it was doing it again. These objects were compact. They were intensely red, and somehow they seemed far more massive than they had any right to be. The discovery raised an uncomfortable possibility. What if our story about the early universe is incomplete? What if something existed in those first few 100 million years that we never imagined? Tiny red points of light had suddenly become one of the biggest mysteries in modern astronomy. But before we can understand why they are so strange, we need to know exactly where they appeared, and why no telescope in history had ever seen them before. Because the next chapter begins with a hidden region of the universe, and a discovery that had been waiting in the dark for billions of years. The universe had been hiding something in the dark. Tiny red lights, ancient, bright, and somehow invisible to us for all of human history. Here's the strange part. These objects weren't rare accidents. They kept appearing, again and again, buried inside the mountain of data sent back by the James Webb Space Telescope. Since its launch on Christmas Day in 2021, Webb has spent more than 32,000 hours staring into space. It has returned over 600 terabytes of information. That's enough data to make even your laptop beg for mercy. And hidden inside this cosmic library were the little red dots. They appeared in a very specific chapter of history. Between roughly 500 million and 1 billion years after the Big Bang. Imagine compressing the entire 13.8 billion year history of the universe into a single year. These objects would show up during the first 2 weeks of January, practically yesterday. By around 600 million years after the Big Bang, they seemed to be everywhere, and then they vanished. About 1.5 billion years later, they disappeared completely. No farewell, no cosmic note saying, "We'll be back." Just gone. Why would an entire population of objects appear and then seemingly go extinct? That mystery alone would have kept astronomers awake at night. But the universe wasn't finished being weird. The little red dots are tiny. Most are less than 500 light years across. For comparison, our own galaxy, the Milky Way, stretches over 100,000 light years. That means these objects are nearly 200 times smaller than our galaxy. Imagine fitting an entire city inside a coffee mug. And yet, they shine with extraordinary brightness. tiny cosmic lanterns burning in the darkness of the early universe, which raises another question. How can something so small produce so much light? For decades, we never saw them because our telescopes simply weren't powerful enough. It's a little like trying to spot a firefly on the other side of a continent while wearing sunglasses. The light from these objects had been stretched by the expansion of the universe. Their glow had shifted into infrared wavelengths, invisible to human eyes, invisible to older telescopes, but not invisible to Webb. The James Webb Space Telescope was specifically designed to see this ancient infrared light, and when it finally opened its golden mirror to the cosmos, there they were, waiting, as if the universe had hidden a secret compartment and only now handed us the key. This is one of the humbling things about science. Sometimes discoveries don't happen because nature changes. They happen because our tools finally become good enough to notice what was there all along. The little red dots may have been sitting quietly in the cosmic attic for 13 billion years. We simply didn't know where to look. But there was one clue that made these objects even stranger: their colour. They weren't just red, they were red in a way that seemed almost impossible, and that unusual shade of crimson would become the first real hint that these objects might be something the universe has never shown us before. The universe had finally shown us these tiny objects. Now it was time to ask a simple question. Why are they so red? At first, astronomers thought they already knew the answer. In astronomy, red usually means old and far away. The universe itself causes this. As space expands, light stretches with it. Like a rubber band being pulled, blue light becomes redder, red becomes infrared. This effect is called redshift. It's one of the great cosmic fingerprints. In fact, nearly every ancient galaxy we observe carries this reddish glow. So when scientists first saw the little red dots, they shrugged. Case closed. They're just very distant objects. Except the numbers didn't agree. The dots were too red, almost suspiciously red, like finding a campfire that's somehow glowing a deeper shade of crimson than fire should allow. Something extra was happening, so astronomers turned to the universe's favourite troublemaker. Dust. Cosmic dust is everywhere. It floats between stars and galaxies, and it behaves a little like fog during sunset. Blue light gets scattered or blocked. Red light slips through more easily. The result is a redder object. This seemed perfectly reasonable. Maybe these ancient objects were wrapped in thick clouds of dust. Mystery solved. Again. Except the universe enjoys ruining perfectly good explanations. When astronomers split the light from the little red dots into its individual colours, something bizarre appeared. Their spectra looked wrong. Not slightly wrong, completely wrong. Instead of a smooth distribution of light, there was a strange valley in the middle, a giant V shape. Imagine listening to an orchestra where the violins and drums are playing loudly, but the entire middle section has vanished. No cellos, no trumpets, just silence. That's essentially what astronomers saw. The objects were emitting huge amounts of ultraviolet light. They were also emitting huge amounts of infrared light. But between those two regions, almost nothing. No known ancient galaxy behaved like this. No ordinary dusty object behaved like this. No standard explanation seemed to fit. The deeper scientists looked, the stranger these little red specks became. And that's one of the beautiful frustrations of science. Sometimes a discovery doesn't answer questions. It manufactures new ones. The little red dots had already challenged our ideas about how quickly objects formed in the early universe. Now they were challenging our understanding of light itself, because light carries secrets. Every atom leaves fingerprints, every star leaves clues, every black hole leaves scars in the radiation around it. And somewhere inside this bizarre V-shaped spectrum was a message, a clue, a signature. Astronomers just had to learn how to read it. Then, hidden inside the light, they noticed something extraordinary. At one precise wavelength, the brightness suddenly jumped. A sharp edge, a cosmic cliff. And that single feature would push this mystery into an entirely new direction. Hidden inside the strange light of the little red dots was a cliff. Not a real cliff, a cliff made of light. At one very precise wavelength, 364.6 nanometers, the brightness suddenly jumped. To astronomers, this feature has a name: the Balmer Break. And for a brief, glorious moment, it looked like the mystery was over, because the Balmer Break is familiar territory. It's one of the fingerprints left behind by young hot stars. Hydrogen atoms absorb and release light in very specific ways, and when millions or billions of young stars shine together, they create this sudden step in the spectrum. It's like hearing a familiar melody in the middle of a strange song. Astronomers thought they recognized the tune. Maybe these little red dots weren't exotic at all. Maybe they were simply furious star factories. Entire galaxies experiencing a cosmic baby boom. After all, the early universe was a busy place. Stars were forming everywhere. Galaxies were colliding. Gas clouds were collapsing. Finding enormous nurseries of young stars didn't sound unreasonable. In fact, the idea was elegant. Young stars could explain the brightness. Dense regions of star formation could explain the compact size. And dusty starburst galaxies already exist in today's universe. Everything seemed to fit. Science loves moments like this. The pieces slide together. The puzzle starts making sense. You can almost hear the champagne corks preparing to pop. Then mathematics entered the room and ruined the party. To make the little red dots as red and bright as observed, the galaxies would need impossible amounts of dust. Not a little extra dust, not twice as much. Nearly 100 times more than theoretical models predicted. Imagine trying to explain a campfire by claiming someone secretly dumped an entire mountain of charcoal onto it. The numbers simply refused to cooperate. Then came the second problem. To generate so much light from stars alone, those stars would have to be packed together at absurd densities. Entire populations of stars squeezed into tiny regions of space, like trying to fit a city of millions inside a football stadium. Gravity would struggle. The gas would behave strangely. The models became increasingly unrealistic. The beautiful explanations started to crack. Then it collapsed. And that's one of the most frustrating and beautiful things about science. Sometimes your favorite idea isn't wrong because someone dislikes it. It's wrong because the universe votes against it. The equations become the jury. And in this case, the verdict was clear. The little red dots could not be ordinary star-forming galaxies. At least, not the way we understand them. The cosmic cliff had led scientists somewhere unexpected. They had followed the fingerprints of stars, only to discover that the fingerprints didn't match the suspect, which raised an uncomfortable question. If stars couldn't explain these objects, then what could? Astronomers began looking toward another engine capable of producing extraordinary amounts of energy. An object so powerful that it can outshine entire galaxies. An object that bends space, swallows light, and sits at the heart of nearly every large galaxy in the universe. A black hole. But that answer would turn out to be just as troubling as the mystery itself. The stars had failed. The equations had spoken. So, astronomers turned towards something far more dangerous. Black holes. If the universe has a Swiss Army knife for explaining strange sources of light, it's a feeding black hole. Give a black hole enough gas and dust, and it becomes a monster. Matter spirals inward. It heats to millions of degrees. It can shine brighter than entire galaxies. Suddenly, the little red dots didn't seem so impossible anymore. In fact, they looked suspiciously familiar. They were bright. They were compact. And when scientists studied their light, they found broad emission lines. That's a fancy way of saying that gas around these objects was moving incredibly fast. Thousands of kilometers per second. Fast enough to travel from New York to London in less than a second. This is exactly the kind of chaos astronomers expect near a feeding black hole. For a moment, the mystery seemed solved again. The little red dots were ancient active black holes. Case closed, except the universe had one more trick. There were no X-rays. This was a problem. Actually, it was a gigantic problem. Feeding black holes are messy eaters. As matter falls inward, it gets squeezed and heated until it emits enormous amounts of X-ray radiation. It's one of their trademarks. Like smoke from a fire. No smoke usually means no fire. But when astronomers looked for X-rays coming from the little red dots, they found almost nothing. Imagine hearing thunder but seeing no lightning, finding shark teeth with no shark. The signature was missing. Somehow these objects looked like black holes while refusing to behave like black holes. Then came an even stranger discovery. The black holes appeared far too massive. Normally, a supermassive black hole accounts for only about 0.1% of the mass of its host galaxy, tiny compared with the galaxy around it, like a pea sitting inside a football stadium. But the little red dots didn't follow the rules. Their black holes seemed to make up nearly 10% of the galaxy's mass, 100 times larger than expected. That would be like finding a skyscraper whose foundation weighs more than the city built around it. Something wasn't right. Either the measurements were wrong, or the early universe was producing gigantic black holes far faster than our theories allowed. And if that were true, then some of our ideas about cosmic evolution might need rewriting. Astronomers found themselves trapped. Stars couldn't explain the observations. Black holes couldn't explain them either. Every answer created a new contradiction. Science occasionally reaches these uncomfortable crossroads, a place where every road ends in fog. And sometimes, when every existing explanation fails, the universe is quietly telling us that we are asking the wrong question. Maybe the little red dots weren't stars. Maybe they weren't ordinary black holes. Maybe they belonged to a category of object that nobody had seriously considered before. A completely new kind of cosmic beast. And somewhere among hundreds of these tiny red lights, one particular object was waiting. An object so strange that it would force astronomers to imagine something that sounds almost impossible. A star, with a black hole hidden inside it. Science doesn't usually say, "I have absolutely no idea." It prefers gentler phrases. More research is needed. The data remain inconclusive. Additional observations are required. But every once in a while, the universe corners scientists into admitting something uncomfortable. Nothing fits. And that's exactly where astronomers found themselves. The little red dots had become a cosmic lose-lose situation. Astrophysicist Fabio Pacucci summarized the problem perfectly. If these objects contained black holes, the black holes were impossibly large. If they were made of stars, the stars were impossibly crowded. Pick your explanation. Break physics anyway. It's a bit like being told that an elephant somehow fits inside a refrigerator. And if it doesn't, then perhaps the refrigerator is secretly the size of a stadium. Either answer sounds ridiculous. This is usually the moment when science gets interesting. Because history shows something strange. Whenever nature refuses every available explanation, a new idea often emerges. The orbit of Mercury didn't fit. Then came Einstein. Galaxies spun too fast. Then came dark matter. The expansion of the universe accelerated. Then came dark energy. Sometimes confusion is not a dead end, it's an invitation. And so, astronomers looked closer. One researcher in particular decided the mystery deserved its own investigation. Astronomer Anna de Graaf launched a project with an appropriately dramatic name. The Rubies Survey. Its mission was simple. Find the reddest and strangest objects in the sky, and ask them what they are. The survey collected spectra from roughly 300 red sources scattered across the cosmos. Among them were dozens of little red dots. Finally, scientists had a larger sample, more data, more clues. Maybe now the mystery would be solved. Instead, it became even stranger. The little red dots were not all the same thing. Some turned out to be dusty galaxies. Others did contain active black holes. A few were almost disappointingly ordinary. The universe had mixed several different kinds of objects into one cosmic bucket and painted them all red. But there was a stubborn group that refused to cooperate. No existing category could explain them. Not stars, not galaxies, not ordinary black holes. They sat there like pieces from the wrong puzzle. This was actually encouraging, because the most exciting discoveries in science often begin with leftovers. The objects that don't fit. The observations that refuse to behave. The data points that everyone initially thinks must be mistakes. Quasars were once strange leftovers. Pulsars were once strange leftovers. Even galaxies outside the Milky Way were once strange leftovers. Maybe these mysterious red objects belonged to that tradition. Maybe they were trying to tell us something entirely new. Among all the unexplained sources, one particular object began attracting attention. It was brighter, stranger. Its light carried clues that seemed almost contradictory. The object would later earn an unforgettable nickname, the Cliff. And hidden inside its spectrum was evidence for one of the most bizarre ideas modern astrophysics has ever considered. An idea that sounded less like astronomy and more like science fiction. What if a black hole could wear a star like a disguise? Every mystery has a moment when things stop being strange and start becoming unbelievable. For the little red dots, that moment arrived in July of 2024. Astronomers found an object unlike anything they had seen before. They gave it a nickname, the Cliff, not because of where it was, but because of what its light was doing. The object sat roughly 11.9 billion light-years away. Its light had been travelling toward Earth for nearly 12 billion years. Long before the Sun existed, long before Earth existed, long before there was anyone around to wonder what it might be, and hidden inside that ancient light was something extraordinary. Its Balmer break was enormous, nearly vertical, twice as strong as any similar object ever observed from the early universe. Imagine listening to a song and suddenly encountering a note so loud that it drowns out the entire orchestra. That's what astronomers saw. The signal was screaming, and it seemed to be saying something very specific. Hydrogen. Lots of hydrogen. The data suggested a huge, dense, remarkably uniform atmosphere made almost entirely of the simplest element in the universe. This sounded almost like a giant star. Problem solved? Not even close, because another part of the same observations pointed in a completely different direction. A supermassive black hole. The gas around the object appeared to be moving at extraordinary speeds. The brightness was enormous. The signatures resembled material swirling around an actively feeding black hole. The universe had just handed astronomers two completely different answers: a giant hydrogen atmosphere, a giant black hole. Both conclusions came from the same object. It was as if a doctor examined a patient and concluded that they were simultaneously a newborn infant and an 80-year-old marathon runner. The evidence simply didn't fit together. Scientists stared at the data, rechecked the calculations, tested alternative explanations. The contradiction refused to disappear. And this is where science becomes wonderfully uncomfortable. Nature doesn't care whether our categories are convenient. Stars, galaxies, black holes, those are human labels. The universe is under no obligation to arrange itself neatly inside our filing cabinets. Perhaps the Cliff wasn't choosing between being a star and a black hole. Perhaps it was both. That idea sounded absurd, but absurd ideas have a strange history in astronomy. Black holes themselves once sounded absurd. Neutron stars sounded absurd. Expanding space sounded absurd. Sometimes today's impossible idea becomes tomorrow's textbook chapter. The object called the Cliff seemed to be inviting astronomers to imagine something entirely new. Something that lived in the blurry territory between stars and black holes. Something with the appearance of one and the engine of the other. A giant sphere of hydrogen, a hidden monster at its center, an object powered not by nuclear fusion, but by a black hole feeding inside it. The idea sounded like science fiction, yet for the first time in this entire mystery, all the strange pieces were beginning to point in the same direction. And that direction led to one of the most fascinating theories in modern astrophysics, the birth of something researchers now call a black hole star. Sometimes the most revolutionary scientific ideas sound completely ridiculous. Continents that move, invisible dark matter, space and time bending, and now a star with a black hole hidden inside it. This was the idea proposed by astronomer Anna de Graaf. What if the object called the Cliff wasn't choosing between being a star and being a black hole? What if it was both at the same time? Imagine a campfire hidden inside a thick fog. You can't see the flames directly. You only see the glow of the mist around it. That, in a way, is the black hole star. At its center sits a growing, supermassive black hole. Around it lies an enormous sphere of dense hydrogen gas. From far away, it would look like a giant star, but inside, it would be something entirely different. Ordinary stars are powered by nuclear fusion, Atoms crash together. Hydrogen becomes helium. Tiny amounts of mass become enormous amounts of energy. The Sun has been doing this for about 4.6 billion years. A black hole star doesn't need fusion. Its power source is gravity itself. Matter falls toward the central black hole. As it spirals inward, it becomes incredibly hot. Enormous amounts of energy are released. The black hole becomes the engine. The surrounding gas becomes the disguise. And suddenly, many of the mysteries surrounding the little red dots begin to untangle. Remember the missing X-rays? They may not have been missing at all. Normally, feeding black holes produce powerful X-rays. But inside a black hole star, those X-rays would struggle to escape. The dense hydrogen envelope acts like a cosmic blanket. The radiation gets trapped, bounced around, absorbed, re-emitted. By the time the energy finally escapes, much of it has been transformed into red and infrared light. The smoke wasn't absent. The chimney was simply hidden. Then there was the impossible brightness. That begins to make sense too. The enormous gas envelope can radiate tremendous amounts of energy without requiring impossible numbers of stars. The object can shine brilliantly while remaining surprisingly compact. For the first time since the discovery of the little red dots, the pieces of the puzzle seemed willing to sit in the same box. The redness, the brightness, the missing X-rays, the strange spectra, the giant hydrogen atmosphere, all of it could emerge naturally from one extraordinary object. Of course, this didn't mean the mystery was solved. Science is careful. A beautiful idea is not automatically a correct idea. The universe has fooled astronomers before. It will probably fool them again. But for the first time, there was a model that didn't immediately collapse under its own weight. And that alone made people pay attention, because if black hole stars truly exist, they represent something extraordinary, a completely new kind of cosmic object, a bridge between stars and black holes, a hidden phase of cosmic history that no one had ever observed before. But one important question still remained. Could this bizarre idea do more than explain a few strange red dots? Could it solve one of astronomy's oldest and biggest mysteries? How did supermassive black holes become so unimaginably large so quickly after the birth of the universe? The next chapter would reveal that the answer may have been hiding inside these strange objects all along. A good theory doesn't just explain one strange fact. It explains many strange facts at once, like finding a single key that opens several locked doors. The black hole star idea had already explained the missing X-rays. It had explained the impossible brightness. But one enormous problem remained: the giant black holes. Remember the numbers. In ordinary galaxies, the central black hole usually contains about 0.1% of the galaxy's mass. Tiny, almost an afterthought. But the little red dots seemed to be different. Their black holes looked enormous, nearly 10% of the mass of the entire galaxy, 100 times larger than expected. If these measurements were correct, astronomers had another crisis on their hands. The early universe would have been producing supermassive black holes at impossible speeds. Then astronomer Rohan Naidu looked at the puzzle differently. What if we were being fooled by light itself? After all, astronomy is a strange science. Nobody has ever touched a galaxy. Nobody has visited a black hole. Everything we know comes from light, and light can be deceptive. Naidu proposed that the little red dots might actually consist of two separate components. First, the black hole star itself. Second, a surrounding host galaxy. The two objects shine together. Their light overlaps, like two songs playing at the same time. And suddenly something remarkable happened. The mysterious V-shaped spectrum appeared naturally. No impossible dust, no bizarre assumptions. The strange fingerprints simply emerged from the combination of two different sources of light. But the biggest surprise came next. The dense hydrogen gas surrounding the black hole doesn't merely hide X-rays, it also scatters light. And that scattering can trick astronomers into overestimating the mass of the black hole, in some cases, by extraordinary amounts. 100 times, 200 times, even 300 times. Imagine stepping into a hall of mirrors and concluding that you're a giant because your reflection looks enormous. The object itself hasn't changed. Only your measurement has. Correcting for this effect transformed the entire mystery. The black holes no longer needed to be impossibly large. The redness no longer required impossible amounts of dust. The observations finally began fitting together. Not perfectly. Science rarely offers perfect endings, but well enough that astronomers could breathe again. For the first time since the discovery of the little red dots, there was a model that explained nearly every strange property: the compact size, the brightness, the missing X-rays, the bizarre spectra, the oversized black holes. The universe had not been breaking the laws of physics. It had simply been speaking a language we didn't yet understand. And slowly, patiently, we were learning to translate. But one question remained hanging in the darkness. Perhaps the biggest question of all, even if black hole stars are real. Why do they matter? Why should we care about a handful of strange red objects that existed billions of years ago? Because hidden inside these tiny points of light may be the answer to one of astronomy's oldest mysteries, a mystery that has haunted scientists for decades. How did the universe create monsters? How did supermassive black holes become so unimaginably huge, so unimaginably fast? The answer may have been growing inside these hidden cocoons all along. Some ideas spend years waiting for the universe to catch up. In 2008, theoretical astrophysicist Mitchell Beagelman proposed something strange: a giant cloud of gas, a black hole growing inside it, an object that looked like a star but behaved like something entirely different. He called them quasi-stars. At the time, they were little more than mathematical creatures. Interesting, exotic, and completely unobserved, like drawing a map to an island nobody had ever seen. Then, 16 years later, the James Webb Space Telescope discovered the little red dots. And suddenly, that old map looked surprisingly familiar. What if these mysterious red objects are the descendants of Beagelman's idea? Or perhaps the very first evidence that quasi-stars, or something very similar, actually existed? If that's true, then the implications are enormous, because astronomy has been haunted by one stubborn question for decades. How did supermassive black holes grow so quickly? We know they existed astonishingly early. Some were already billions of times heavier than the Sun, less than 1 billion years after the Big Bang. That's a problem. A very big problem. Growing a black hole is difficult. Even if it eats continuously, there are limits. Too much infalling matter creates radiation. Too much radiation pushes material away. It's like trying to drink from a fire hose while the hose is trying to blast you backward. The clock simply doesn't seem to provide enough time. Yet, the monsters exist. The universe somehow built them anyway. And this is where the black hole star idea becomes so intriguing. Imagine a black hole hidden inside an enormous cocoon of gas. The cocoon traps much of the radiation. It keeps the growing black hole fed, protected, well supplied, a cosmic nursery. Instead of growing in the open, the black hole matures inside a giant blanket of hydrogen, and by the time the cocoon disappears, the monster has already formed. Suddenly, one of astronomy's oldest puzzles begins to soften. The little red dots may not simply be strange objects. They may be snapshots of a missing chapter in cosmic history, a brief phase that existed only in the young universe, a stage that lasted perhaps a few 100 million years before conditions changed, and these objects vanished forever. Remember how the little red dots disappeared roughly 1.5 billion years after the Big Bang? Perhaps nothing mysterious happened to them at all. Perhaps the universe simply outgrew the conditions required to create them. The cosmic nursery closed, the babies remained, and today those babies may sit at the centers of giant galaxies, including our own. At the heart of the Milky Way lies a supermassive black hole called Sagittarius, a star, a dark giant weighing more than 4 million suns. Did it once pass through a hidden phase like this? We don't know. That's the honest answer. The black hole star theory remains unconfirmed. More observations are needed. More data. More surprises. Science rarely ends with certainty. It usually ends with a better question. And perhaps that's the real gift of the little red dots. They remind us that the universe is still full of unopened chapters. Tiny points of red light, scattered across the darkness, maybe whispering the story of how the first cosmic giants were born, a story hidden for nearly 13 billion years. And perhaps, somewhere in the next image sent back by James Webb, the universe is already preparing its next impossible surprise.